Hello, viewers. I'm Anadol Gu.
And my name is Avir Singh. And today we're going to be talking about pumped hydro stations.
An analysis into increasing the reliability and large-scale dependence on renewable energy sources. As a taste for what's to come, here's a preview. Our research has found that pumped hydro stations have the potential to revolutionize the world and its use of renewable energy. It also has the potential for large-scale applicability. Introduction. As much as we may want to immediately switch to using cleaner energy sources, this is not a simple feat. The issue is that renewable energy sources are not as reliable as traditional non-renewable sources. This is because they are easily influenced by factors like the weather, and as such are subject to fluctuating levels of energy production. The importance. As a holistic outlook, as long as this remains an issue, renewable energy sources cannot become a predominant source of energy. As such, the world will still need to depend on fossil fuels and other old methods of energy production that are harmful to the environment and continue to contribute to climate change. On a smaller scale, inconsistent energy supply from renewable sources means alterations in the frequency of the power grid, which can cause power outages and even break or damage certain machines and devices that rely on a specific oscillating frequency in order to function properly. A solution is to use large batteries, which can store energy and then release it into the grid whenever excess energy is needed. While there is a multitude of different large-scale batteries, most of them are either too new to be fully dependable, or they may be too expensive. The most common and globally used big battery is pumped hydropower storage. Pumped hydropower storage accounts for 94% of globally installed energy storage capacity. Therefore, we would not be implementing a brand new idea, but rather an idea that already works.
Pumped hydro stations connect to the power grid and use gravity and borrowed energy to pump water from a lower reservoir up to a higher reservoir. Water is pumped back and forth between the lower and the upper reservoirs, essentially storing and then releasing energy. The amount of energy that a pumped hydro station can generate depends on the size of the turbine, while the station's storage capacity depends on the size of its two reservoirs.
Why Vancouver? Well, due to Vancouver's higher reliance on renewable energy sources, which are volatile and inconsistent with the amount of energy they produce, Vancouver needs the assurance that their power grid will have a consistent supply of energy. The large changes in geographical elevation provided by the Rocky Mountains makes for an ideal location for a pumped hydro storage station, as it allows for higher levels of production of energy. We mentioned that in Vancouver has a reliance on renewable energy sources. Well, in fact, 98% of Vancouver's energy comes from renewable energy sources. Due to this high reliance, Vancouver is liable to fluctuating energy production, which means inconsistent supply of energy to the power grid, thus making it an ideal candidate for hydro pump storage stations.
For our data, we used one large data set along with several smaller facts and statistics. We inputted all of our data into Microsoft Excel and used it to create our graphs. We also used Microsoft Excel to calculate the standard deviation and make a column chart. The findings of our research. Our first graph shows the predicted population and energy consumption of Metro Vancouver, and what we found was that the predicted population is expected to increase from about 2.6 million to 3.8 million from 2016 to 2015. And with that increase, the annual energy consumption is priced to increase from 33.5 million megawatts to 49 million megawatts. These are both 48% increases. Our graph makes it very clear that more energy will be demanded in the future. If Vancouver continues to obtain most of its energy from renewable sources, this puts an increased strain on energy production and is even more of a reason to implement a pumped hydro station to ensure consistent supply of electricity. Even if energy consumption does not increase as steeply as we predicted, overall, demand will still increase simply due to Vancouver having a larger population.
After looking at predicted population and energy consumption, we decided to analyze the area control error. This second graph shows the BC hydro area control error in 10-minute intervals from 11 a.m. on January 22nd, 2020 to 11:50 on December 31st, 2020. This is a one-year interval. The area control error measures the difference between the predicted electrical generation versus the actual electrical generation of the power grid, taking into account any known meter error and frequency biases. When the area control error is below zero, it means that electricity was underproduced in that specific time frame, and when it is above zero, vice versa. Area control error volatility is depicted by how scattered the dots are. When looking at the graph, it is apparent to see that the area control error is less accurate in the winter months, which are located towards the ends of the graph, and is more accurate in the summer months, depicted in the center of the graph. This trend can also be seen in our next graph, the standard deviation of the previous area control error graph. The data is broken up into fiscal quarters to represent the change in seasons and therefore weather. When we see the standard deviation is higher in quarters in the winter months, quarter one, which indicates the area control error being less accurate compared to the summer months located in quarter three, where the standard deviation is lower and the area control error is more accurate.
The area control error matters as it shows how climate change is already having an impact on electricity generation in Vancouver. We also chose to calculate the standard deviation of the area control error in order to numerically represent the sporadicity of the area control error. We hypothesized that because of climate change, winters are becoming less and less predictable, making it difficult to forecast the power load. This further shows the need for a pumped hydro storage station, storing electricity for the Vancouver power grid to quickly provide electricity as the forecast for electricity demand inevitably continues to become less accurate due to climate change.
Sources of error. The data from our first graph, which showed the predicted increase in population and energy consumption, was calculated assuming that the energy consumption rate per capita would stay the same throughout the calculated time frame, and that the population of the Metro Vancouver increases without any major disturbances, such as a natural disaster. Additionally, the area control error data only looked at 1 year, 2020, and the electrical demands throughout that 1 year, so multi-year trends were not observed. With this in mind, it is important to note that a single year may not be an accurate representation of the average demand of electricity in British Columbia. Furthermore, we chose to focus on 2020, therefore meaning the COVID-19 pandemic could have played a significant role in our findings and trends observed. A counter-argument can be made that the reason for the decrease in standard deviation of the area control error could be because of the COVID-19 pandemic. However, further research would have to be conducted to confirm this possibility.
Moreover, given the limited time frame that we had to conduct our research, only two variables were able to be properly reviewed, that being the growth in population and the area control error. So we would strongly suggest or strongly encourage other research groups to look into this question using more variables and statistics. Finally, the standard deviation is calculated by looking at the different fiscal quarters of 2020 and breaks up the entire year into quarters. This may have grouped too many sections together and too many different trends may have been grouped together.
Future areas of research. Some future areas of research include analyzing the storage capacity of pumped hydro stations in relation to the size of the two reservoirs in order to optimize storage capacity. We could also look at the cost of implementing a pumped hydro station. Researchers could also potentially look at the cost of building hydro pump stations and use that data in order to estimate the cost of building one in Vancouver.
Another big area of research will be determining the environmental impacts of building a pumped hydro station in Vancouver. Hydro stations are big structures that could potentially alter the waterways of a natural ecosystem, so research would have to be conducted to find the optimal spot to build it without destroying sensitive ecosystems. Research could also be done to analyze other possible locations for a pumped hydro station, using the same method of analyzing the area control error and predicted power demand. Finally, if a station were to be built, infrastructure would need to be built to connect the station to the broader Vancouver power grid, So research will have to be conducted on that front.
Conclusions. The main takeaways is that consistent energy is essential. Therefore, some sort of energy storage mechanism will be needed. Pumped hydro station is a solution as the most used and most developed method of storage. Third, it's a large-scale applicability. Further research will have to be conducted, but similar research and analysis methods can be used to study similar geographic areas to Vancouver. Lastly, continued research is definitely included. This has the potential to revolutionize dependability and renewable energy sources.
Thank you for listening, and thank you so much for your time.